Fine, guys, let's start. Okay, so we are currently in our feature engineering series. Okay, yeah, sorry. So currently we are in feature engineering series, and we have seen the overview of feature engineering. Fine, and we have seen different types of feature engineering. And in that we have covered mainly in the feature transformation. We have seen we have seen what we have seen feature scaling. Okay, and also we have seen encoding, handling categorical features. Fine. So in the feature scaling we have discussed what standardization and normalization, and in encoding we have seen what did we see, ordinal encoding and label encoding. Okay, fine. So now if you see this picture, we have understood that if it is categorical and if it is ordinal, then you can go for ordinal encoding. Okay, for this we have already seen the code example. And there is one separate type of label encoding which we specifically use it for only labels, as the name suggests. Okay, this is good. Now coming to the other side, where if the categorical variable is nominal in nature, that means there is no order. Fine, like colors, blue, red, green, there is no specific order. Or the cities. Okay, so there is no specific order. So for this, these are nominal in nature. So here we have a specific type of encoding which we can use, called as OneHot encoding. Okay, so using this we can encode. What is the basic idea of encoding? To just convert the given categorical data into some form of numerical data. Fine. Okay, cool. So now let's try to understand OneHot encoding is. Okay, so over here, if you see, the basic idea of OneHot encoding is, the name suggests one hot. Okay, what does this mean? Only one particular feature will be hot. Hot in the sense one. Okay, so in this language, hot in the sense one. Okay, cold will be zero. Okay, so over here we'll try to understand with an example. So let's say you have this feature. Feature is color. Okay, we have red, blue, green, blue. Okay, obviously this is categorical in nature, and also we can see that this is nominal in nature. That means there is no order. We cannot say red is greater than blue or blue is greater than green. No, fine. So as we understand that we cannot directly pass this column to any system, okay, or any model, so you need to encode this. Okay, so we use this specific type of OneHot encoding, which will try to encode into some other. Okay, this is also a form of feature transformation, right? We are converting the given column into some other column. Okay, so over here, see, we'll try to understand. So what happens in OneHot encoding is it will try to create new features. Okay, so that only that particular value, whatever there, that will be hot. That means one, and remaining everything will be zero. Okay, so we'll try to understand. See, first of all, what happens is, let's say in color, how many categories you have? You have three categories. Okay, red, blue, green. Okay, this is again blue. Okay, so unique counts, unique values in this color feature is red, blue, green. Okay, so it will create those many number of new features as equal to those many number of unique categories. Okay, as an example, red, blue, green, you have three I would say unique categories in this column. So it will create three features. Okay, this is color red, so it will use the feature color and the category color. Okay, sorry, feature name, color, and category name red. Okay, so color red, color blue, color green, like that it will create three columns. Okay, color red, color blue, color green. Okay, so after that, now if you see for this red, okay, what does this mean? So only for this red single value, so it has created three values. Okay, red, blue, green, and this value is red. That means only in the red feature it will have one, remaining will be zero. Okay, that's why when you have red, it is red, red is one. In the under the red column you will have one, and remaining will be zero. That means what? In any row only one value will be hot. Hot in the sense it will have some value one. Okay, it will have only one. Okay, remaining all will be zero. So that's why it's called OneHot. That means only one value will be hot in any given column. Here it will be one. Why? Because this row is for blue row. Okay, this is blue. Only wherever you have color blue, that will have one, remaining all will be zero. Getting? And this is green row. So only wherever you have green, there it will be one, and remaining will be zero. Again, it is blue. Only where you have blue, it will be one, and remaining will be zero. Getting? Getting, guys?
Yes, sir.
Fine. So that's how the new number of features will be created. Okay, so this applies even if the number of columns is high. That means even if you have 50 different colors, okay, let's say in this color you have 50 different unique colors, okay, and let's say you are overall having you are having 1,000 rows, and in that 1,000 rows you have unique 50 columns, okay, then also it will create 50 features, okay, and accordingly it will fill up the values. Fine. So obviously this is one more way of encoding. Ultimately, what is encoding? Converting categorical value into some numerical value. In previous example, we have seen, okay, here what we have done here also, you are given some value, okay, you are given some value, average, UG, these are characters, okay, which we cannot understand. So you convert it into some numbers, okay, whatever be the encoding you use. Here we have used ordinal encoding, okay, obviously it is encoding, and you have some label encoding. There also you are encoding into some value like 0, 1, 2. Similarly, here also you are given the categorical value, you are converting into some numerical value, okay. So this is OneHot encoding. Fine. So this is fine. Okay. Now, any doubts, guys, still here? Okay, fine. So fine. So now, once we understood the basic concept, so as I said, even if there are any number of unique values, also it will create as many number of those features. Okay, that's fine. And there is something called as dummy variable trap, guys. Okay, dummy variable trap in the sense, what happens is there is something called as multi-collinearity. Okay, so when we are discussing linear regression, I will let you know what is this, but just as of now, I am showing you. Okay, so you have something called as multi-collinearity. Okay, so where in the sense it discusses there should be several independent variables. Okay, so that are getting correlated. That means what? See, I'll give you a basic fundamental idea. Okay, this we will discuss in detail when we are discussing linear regression, but as of now, see here, guys. Okay, what's happening over here is, see, we need to discuss. Sorry, just give me a second. See, so there is one interesting concept we need to understand. See, we need to go to the basics of ML, guys. Fundamentally, what is ML? So you are having X, this is Y. Here it could be X1, X2, let's say X10. Okay, and this is Y. Now, the whole point of machine learning is, given these 10 features, you need to be able to predict this Y. Okay, that means you are passing 10 different features. That's the point. You are passing 10 different features. Based upon those features, you should be able to predict the Y variable. Getting? So, because that is the idea. Okay, now that is the idea. Now, it internally means that all these 10 features should be independent of each other. Okay, all these 10 features should be independent of each other. Then only you will be able to know, okay, what is the contribution of each feature in predicting the output variable. Okay, so if at all these two are interrelated, so why to use two columns? You can combine this and create only one row, right? The whole point of using ML model is that when you are passing certain features, those features should help us in predicting the output variable. Okay, and these features, okay, these features, whatever we are saying, right? So those should be independent of each other. Okay, only then you will be able to know, okay, that it is because of this feature this result is occurring. Okay, and because of this F2 feature, this change is happening in the Y variable. Okay, when that will happen? Only when all the F1, feature 1, feature 2, feature 10, when all of these are independent of each other, this will happen. But let's say there is some relationship between F1 and F2, or let's say F2 and F10, there is some relation. Okay, so now when there is some relation between these two, okay, that means what? If F2 is increasing, F10 is decreasing, something like that, then you cannot be very sure, okay, whether whatever the result you are seeing in Y, that is because of F2 or that is because of F10. You're not sure, because there is again relationship between F2 and F10. Getting? Our aim should be, there should be relationship between input and output. That means between X and Y, there should be some relationship, but not in between X and X. Okay, this should not be there. Okay, there should be relation between input and output. That is fair, that is desired. But internally there should not be any relation, because if if you're having F2 and F10 are related, then you cannot definitely say whether the change that is happening Okay, whether the change that we are seeing when we are changing these values, okay, when you are changing these values, there will be some change happening in y. So if there is some relationship between these two also, you cannot be very sure whether f2 is contributing or f10 is contributing. Okay, then there will be a confusion. For example, let's say f1 and f2 are very, very independent of each other. For example, let's say f1, okay, f1 is let's say f2 is designation, okay, and f10 is salary, okay, and f1 is name, just as an example. So if you see, there is no relationship between name and designation. Agree? And also name and salary also, there is no designation. Sorry, there is no correlation. But with designation and salary, there is a clear positive correlation. That means if designation increase, most probably salary will also increase. Fine. So now when you are passing a specific input and you are getting some output, now if you are changing this input, this output will also change. Okay. Some whether increase or decrease, there will be some change. Okay. Now you can, if you ignore every feature except f1, let's say you are considering only f1, because f1 is independent of every other feature, you can definitely say what is the change in output when you are changing f1. Okay, that is happening. But let's say if there is some internal relationship between f2 and f10, okay, f2 and f10, now if you are changing f2, automatically f10 is also changing. You are not directly changing f10, but because there is some relationship existing between f2 and f10, if you just touch f2, it will internally change f10 also. Fine. If you change resignation from 1 to 4, salary will also increase. Let's say from 4 lakhs to 10 lakhs, it must increase. Fine. So you are changing only one feature, but it is internally changing some other feature. Because of that, you are getting some other value. So the new value, whatever you are getting, might not be only because of f2. Okay, because there is also some contribution from f10 also. Getting? Are you guys on track?
Yes, Santosh.
Meghana?
Sure.
Fine. So now that will create a problem. Okay, because you will not be very sure in telling what is the contribution of each and every feature. Okay, this type of situation is called multi-collinearity. Okay, so over here, if you see, this is statistical concept where several independent variables are correlated. Okay, that means there is some correlation between the variables itself. Okay, between variable and feature, that's fine. But in between variables only, if you're having correlation, that is the problem. And this problem is called multi-collinearity. Okay, and the problem here is it will be difficult for us, okay, to track what is the contribution of each and every feature. But ultimately, you can get the results. Okay, that is important point. If you are doubting, so what happens if there is some correlation between the internal features? Ultimate thing, what we want is a result. Okay, that is fine. So when we're discussing this, I'll tell you, but to let you know now, the output will not affect. Okay, so whether it is directly impacting f2 or indirectly, that is fine, but output will be same. Okay, but still we do not encourage this, because the whole point is we should pass independent features. The features should be independent of each other. Okay, so because when there is some correlation, why use two features? Mix them and create new feature, right? Okay, because the more features you are passing, the more difficult it will be for the model to understand the correlation between input and output. That comes under a specific concept called as curse of dimensionality, guys. Okay, it's called curse of dimensionality. We'll discuss it in upcoming classes. Okay, because it means that the more features, see, features are very important for a model. Okay, but if you increase more and more features, it will be very difficult for the model to understand it. Okay, so that's why it is always it will always helpful to have as many less features as possible. Okay, so that's the reason. If you're already having some relation between two features, why to use two features? Just use some code, apply, or do some feature extraction or construction, mix them into one and send it. Okay, so for example, here I'm saying designation salary. You can mix them into two, and let's say some column. I don't. Let's say you say some status, or you can say some position, something like that. Create new feature and create a new value instead of two. Okay, so now this concept where you are having internal features getting correlated is called as multi-collinearity. Okay, is this concept clear? First, then we will go to how this is related to OneHot encoding.
Yes, sir. Clear.
Okay, so now if you see over here, what happens here is, in this concept also, in the multi-collinearity also, what's happening here is, give me a second. Okay, so here also what will happen is, when you are having this, okay, see, focus here, you are having 1 0 0. Okay, you're having 0, 1, 0. That's fine. But the problem here is you are using 3 features, right? So instead of using 3 features, okay, instead of using 3 features, even if you remove one feature also, still you will be able to get the same output. How? For example, let's say you are having 1, 0, 0. Now, what I will say, I will just use red and blue. Okay, I will just say red and blue. Okay, I will not use this green column. Okay, now what happens when I'm saying 1 and 0? Okay, let's say let's assume you are not seeing this color green. Okay, so out of 3 columns, it is created only 2 features. Okay, red and blue. Now let's say you are having 1, 0. Now when it's 1, 0, what is this row representing as? Which color this row is representing? Tell me this. So when you are having only 1 and 0, okay, for example, okay, just forget about this. Okay, this input. Just by looking about only these 2 rows, we are having red, color blue. Okay, here you are having this value 1 and 0. Now what is this row representing?
Red color.
Red color. Agree. Now what is this row representing? 1, 0 and 1?
Blue.
Blue color. Now what is this color will represent 0 and 0?
Don't have any, I mean, other than red and blue, we have some different color for that.
Yeah, obviously green, right? Because the overall
Yes.
colors are red, blue, green. Okay.
Yes,
So
yes, sir.
when you are having red 0, blue 0, so the other option is obviously this row should belong to green.
Yes.
Getting?
Yes, yes.
Now this one, blue.
Blue, yes.
Right? So whatever the value you are able to achieve from three columns, you are able to achieve from 2 columns also. Fine, because the third column, it's not for green. Even if you remove red or blue also, you can guess the third one. Okay, so even if you remove the one column, so that column can easily be predicted from remaining 2 columns, because if all the other columns are 0, so obviously that particular column will be 1. Getting? So if all these 2 are 0, this will 1. For example, let's say you remove this. Okay, so obviously if it is 1, wherever you are, if it is 1, directly red. Okay, if you're having both red and green 0, so obviously this row will belong to blue, because 0 is not present here. Sorry, 1 is not present here and here. Then the only option left is it should be for the blue. Okay, we are just not using this blue. Okay, but obviously we'll understand that the one is going to the blue column. So obviously this row belongs to color blue. Getting?
Yes, sir.
Yes, Santosh.
Right. So that's why. So instead of using, for example, you are having 3 unique columns. Okay, number of unique columns are 3. Okay, so you can use 3 these are OneHot encoded columns, guys. Okay, this is the actual column. So all these which the OneHot encoded columns will create, right? So all these are called OneHot encoded columns. Okay, so if you have 3 unique columns, okay, it usually comes up with 3 OneHot encode OHE. It called OneHot encoding. Okay, OHE. Okay, it will create 3 OneHot encoding columns. Okay, but when it creates 3 OneHot encoding columns for 3 incoming rows, there will be a problem of multi-collinearity, because any one column can be predicted from other 2 columns. Okay, so that's the reason we will remove one. Okay, because one column is dummy, right? In other words, agree? Because any one column can be called as dummy, because if you remove these 2 columns, I'm able to predict this. So one of this column is dummy. Fine. So that's the reason we will use only n-1. So if it is 3, we will use only 2 OneHot encoded columns. Okay, because with the help of only these 2, I can predict the other column very easily. If I'm having 10 unique categories, so I will use only 9 OneHot encoding columns. Getting? So the other one will be dummy. Okay, so we should not use that. Okay, so if you use that, we are falling into something called as dummy variable trap. Okay, so because it's a dummy and you are unnecessarily using, okay, so you're increasing one more feature, okay, which will unnecessarily create multi-collinearity, etc. Getting? So that's why we don't fall into this trap. So I will show during code also how you can just simply control it with one single hyperparameter, where it will only it will just drop one column from the created columns. Okay, so you will have n-1. That means if n is the number of unique categories in a column, so we will have n-1 columns. Getting?
Yeah, Santosh.
Clear, guys? Any doubts still here? Let me know. No? Okay, fine. So now what happens over here? Till here it's fine. Okay, so we understood what is basic one-hot encoding, how you can convert, how it converts. Okay, what does this values mean, why it's called one-hot encoding, and then what is a dummy variable trap. Okay, but there is also one more thing called as OH using most frequent variables. Okay, that means, let's say, see, OHC can create as many number of features. Okay, but the problem here is, if you are having, let's say you are having a car brand column. Okay, car brand column. Okay, and let's say you are having 50 brands. Okay, like Hyundai, Kia, whatever it is. Okay, so Hero, etc, etc. Okay, so it will create obviously how many columns, guys? 50 one-hot encodings. Okay, so if you don't fall into this trap, it will create, let's say, 49. Okay, but still 40 just from one column, guys, getting just from one column you are getting 49 new columns. Agree? And let's say here you are having, what is this? Let's say here you are having fuel type. Okay, fuel type will be what? Fuel type would be like petrol, diesel, gas. Okay, and these are also categorical. For this also it will create how many? 3 minus 1, 2 OHC columns. Okay, this 49 are for only this car brand. Okay, like Hyundai. Okay, let's say what is this? A Maruti. Okay, etc, etc, etc. Okay, this is for fuel type. Like that, if you have few more columns, okay, obviously this count will go into huge number. Agree? Getting this concept, what I'm trying to say? No, you don't understand this?
Can you please repeat once?
Yeah, see, what I'm saying here is, let's say you're working on a data set where you are having this row. What is this row? This row is called as car brand is row. Car brand is a row. Inside this, you're having all the car brands. Okay. Now, let's say you are having 50, let's say it is having 1,000 rows. Okay. In this 1,000 rows, 50 unique car brands are there. That means if you use car dot unique, okay, in unique, you will get how many unique values are there, right? Okay, so it is having 50 unique values. Okay, like for example, see here, guys, here how many values are there? 4 values, but how many unique values are there?
3.
Like that, let's say you are having a data set with 1,000 rows, but unique values are 50.
Okay,
Hyundai, Maruti, like the 50. Now there is another column in the data set called as fuel. Like that, obviously this will also have 1,000 rows, but unique columns are only 3: petrol, diesel, gas.
yes.
Okay, now if you apply this concept here, we applied it for only one column. Okay, but in practical data set we'll have many columns. So for example, on this car brand column you applied, okay, total 50 unique values. So how many it will create? Let's say 49 OHC columns it is creating.
Yes.
Correct? Just like how it created for 4, it has created let's say 3 unique columns. It created 2 OHC, like red and blue. Let's say you are dropping the dummy variable.
Yes.
Like that also for 50, it will create 49 OHC columns for car brand.
Yes.
Then it will come to fuel. And what does this columns look like? Car brand underscore Hyundai, car brand underscore Maruti, like that. Just like how you're seeing color underscore red, color underscore, like that. Okay.
Yes.
Next it will come to fuel. Then it will create 3 minus 1, 2 OHC columns for this fuel underscore petrol, fuel underscore diesel. Getting?
Yes. Yes.
So here only how many you got? 51 rows are there. Let's say if you have few more columns, let's say whatever it could be, fuel, manufacturing, or a city, okay, which country, etc. So this value is increasing, right?
Yes.
From 51, let's say overall you are having, let's say you have one more column also called as city or country. For example, you are having country, okay, and country you are having India, America, China, Japan, like that. Let's say you are having 10 different countries. So 9 will be your OHC columns for that.
Yes.
So how many over? 49, 9, 2. Okay, 60. Agree?
Yes. 60,
still it is a big number. Fine. 60 handling, passing 60 columns to a model is still different, because it should understand, it should consider for every row, it will have 60 columns, 60 values and corresponding output value. And for us to understand the relationship between all this and how the output value will change based upon every input is a tedious job. Agree? No?
Understood, Santosh.
So for that, we can also handle, you can, instead of converting every column into OHC, you can also do only for most frequent variables. Okay, that means if at all, if any column is having, if the unique categories, for example, here we are having 50 unique categories. Okay, so it is having very high, okay, then only you can consider. If it is having only small number of unique categories, you may not, okay, you can just put a threshold and then you can convert only those columns. How you can do, we'll see with an example, okay. But before that, let me know, guys, next we'll go to the code and I'll show you a practical example, okay. But before that, let me know, is the theory part clear? Any confusions, any doubts, guys?
Clear, Santosh.
Okay, fine. So now let's see, guys. Okay, now we'll go to, okay, see, yeah, in OneHot encoding, okay, so I have considered this example cars dataset, okay. So this is cars, no, this is not cars, okay. So over here you are having exactly brand, okay, kilometers driven, fuel, okay, owner, selling. Okay, first let's look at a data set. Okay, so this is my data set. Agree? So now when you do value counts, what does it give? Pandas function, it will give you the count of each and every category in that given column. Okay, for example, when I say df.owner, okay, in owner, how many value counts, in the sense how many different categories are there and what is the count of each category? Okay, first owner is 5,000, second owner is 2,000, like that. Okay, for example, let's say I'm saying brand. Okay, in brand column, see, there are these many categories are there and these are their corresponding values. Okay, there are 2448 Maruti values are there, Toyota Tata 734 and Ashok MG3, like that. Agree? So using value counts you can get that. Okay, and also let's say you are having owner. Okay, okay, so owner you are having only first, second, third, fourth and above test drive. Okay, so these are the categories. Now when you use OneHot encoding, so just to tell you, there are two ways how you can create OneHot encoding, guys. Okay, this is important. Okay, so OneHot encoding, okay, there are two ways. One is pandas, okay, one is sklearn. Okay, now sklearn is machine learning library, pandas is basic Python library. Agree? So using pandas, you use a function called as dummies. Okay, in sklearn you use something called as OneHot encoder. Okay, the output will be same. Okay, but there are just two different ways how you can create. Okay, we'll see both. Okay, so pd.dummies will also create dummy variables like OneHot encoded values. sklearn, if you want to go by the actual sklearn library, machine learning library also, then that is also fine. Okay, so for example, initially we'll see using pandas. Okay, so pd, okay, this pd is pandas get dummies. Okay, get dummies for what? This is my data frame, df is my data frame. Okay, so in that I'm passing only these columns. Okay, for fuel and owner, only for these two columns give me dummy variables. Okay, so that's why if you see, you are having brand, kilometer, okay, and selling price. See, obviously kilometer and selling price are numerical values. Okay, they're not categorical, so there is no need of encoding. Okay, so but you specify only fuel and owner, so it will consider only these two for OneHot encoding. Okay, for example, if you see here, brand and kilometer driving, they're untouched. Okay, but in fuel, what was the unique categories, guys? If you remember, in fuel you're having diesel, petrol, CNG, LPG, so it will create four values. Okay, so diesel, fuel and its category name. Okay, getting? So you are having what? You are having diesel, petrol, CNG and what, LPG. So fuel, CNG, fuel, diesel, fuel, LPG, fuel, petrol. Getting is? Okay, and over here if you see, okay, just if I show you a few examples, in the first row, okay, so over here if you see in the fuel, the first are diesel, petrol, okay, the first two are diesel. So see, only concentrate on this particular OneHot encodings. Okay, so first is diesel, right? So only wherever you are having diesel, it will be 1. Okay, so that's why you are having 1. Okay, all these are zeros. Agree? Next also diesel. Okay, diesel, zeros. Next is petrol, all zeros. Next is again diesel, zeros. Getting?
Yeah, got it, Santosh.
Similarly for owner also, if you see first owner, second, third, so total how many categories are there? 5 categories, so it will create 5. So how it is creating the names also, you see the column name underscore category name, owner, first owner, owner, second owner. Okay, see, owner, first owner, owner. The order might be different. See, the owner, first owner, second owner, owner, third owner, owner, fourth owner, and owner test drive. And here, if you see, the first is first owner. So that's why in the first owner, we are having 1, remaining all zeros. And the next is second owner. So that's why wherever you're having second owner, it is having 1, remaining all zeros. And last is third owner. So here it is third owner and remaining all it is 0. Clear?
Yes, sir. Clear.
Okay.
Yes, Santosh.
Simple. Fine. So now we're asking something, Karthik?
No, Santosh. I will ask in the letter.
Okay. So this is how you can create using dummies. Okay. So now when I say this dummy variable trap, right? So when I say dummy variable trap, so over here, that means you can drop. So instead of just now we discussed it. So instead of why for example, this owner only you're having 1, 2, 3, 4, 5. So for 5 unique values is 5, it has created 5 columns. Okay, but why 5? I can use it with only 4. Okay, so you need to drop one. How you will drop? That is important. So using the same function, how you are creating the same function, but there is one more parameter. Okay, it's called drop first equal to true. By default, it will be false. Okay, by default it will be false. Okay, so that's the reason. So whenever you are using something, so it's always better to go for the documentation. Okay, for example, you are having dummies. Okay, pandas dummies. Okay, get dummies. You need to go to the official documentation, and if you see over there, see get dummies. Drop first is by default it is false. Okay, and if you see here drop first, where you get the k-1 dummies instead of k. Okay, so that's why by default it will false. If you put it as true, so instead of 4 fuel, it will create only 3 fuel. Okay, instead of 5 owner values, it will create only 4. Getting? So that's why if you see, okay, if you see here, this is 0, 1, 0, 0. Okay, so what is this? What it has dropped? It has dropped CNG. Okay, it has dropped CNG. Okay, but even if it is not, but because we are having it is for diesel, so it is fine. Okay, but wherever you are having CNG, for example, here you are having CNG equal to 1. Okay, so in that scenario, or when you are dropping 1, so all diesel, LPG, petrol will be 0. This 0, 0, 0, which internally means that this row belongs to this, but that particular row belongs to CNG. Because if everything is 0, there is no only option left is the CNG should be 1. Getting, guys?
Yeah, Santosh, got it. If something is not there, then everything will become 0. So that is also one of the
Correct.
case.
Correct. For example, see here only I will show you an example. See consider this owner categories. Okay, in owner categories, what is this first row belongs to? Which category it is belonging to? For example,
First owner.
if I go here and show you the first in owner, it is first owner. This is categorical value. Okay.
Yes.
So that's why what we have done. So that's why we have, if you come down, yeah, this first row belongs to first owner. Why? Because you are here it is having 1. Agree? That's why this belongs to 1. But now if you see in the k-1, when we are using drop first equal true, it has dropped this column. It has dropped this column. There is no first owner. See here. Agree?
Yes.
So now for the same first row, what are the values? Okay, see, when you are able to say this row belongs to first owner, okay, how you are able to say, because there is 1 under this column. But when that column is not there, now if just by looking at these values, okay, just look at these values, 4 values, and tell me which row do this belong to?
First owner, because all are zeros.
Because
So,
correct. So because all these are 0, but actual categories are same. I'm not dropping the category itself. I'm just dropping the column. Okay, but the actual category first owner is there because that is from the original data set. Agree? But I'm not just considering here because there is no need, because just from these 4 values, because all these are 4, obviously the 1 should obviously go in this case to first owner. Okay, that the system will understand. Okay, the only thing is it is not showing us and it is not using it. Getting, guys? Internally it will consider this. Okay, whenever all these are 4, internally while doing predictions or everything, it is assigning this value to this first owner category. Okay, but it is not specifically creating a column and wasting the space and unnecessarily introducing multicollinearity. Getting?
yes, Santosh.
Correct. So obviously, how we are understanding, it will understand the same way. So when all these are 4, so obviously this row belongs to first owner. Clear, Meghana? Karthik?
Clear.
Okay. Okay. Fine. So this is how you can go with the drop first rule. Okay. So this is how you can avoid the dummy variable trap. Okay. This is the basic encoding, and second thing is a dummy variable trap. Fine. So then apart from that, now we are going to, as I said, we are going to use this using the pandas, guys. Okay. Now using the sklearn, which is the most famous one and which we generally use. Okay. There you have something called as OneHot encoder. Okay. The first thing we are going to do is just do a train test split. Train test split. Okay. So using model selection, you are importing train test split and you are passing this. This is X. Okay. I think by now you understand how you are passing X and how you are passing Y. Okay. And this is test size random state. And you're getting X10, Y10, X test, Y test. Okay. So as I said, we will do encoding on train. Okay, we'll fit it on encoding and we'll pass it to both. We'll apply it on both test and train and test. Remember, we fit any type of encoding, whether it is standardization or normalization or OneHot encoding. We train, that means we fit it on training data, but we apply, transform it to both training data and test data. Remember this concept or forgot, guys?
Remember, on the first day you have
Right.
told.
Okay. So now over here, so this is my training data set. Okay. So the way how you are importing OneHot encoding is simple. Okay. From sklearn or pre-processing, import OneHot encoder. Okay. So over here, I'm saying in a OneHot encoder, okay, I'm saying drop first. Okay, same thing. The sparse, false, and data type is by default you can use the by default values. Okay, but if you're interested, you can go for the I would say OneHot encoder. Okay, so for the documentation. Okay, so here if you see, the basic thing is drop first. Okay, so where it is drop is none. Okay, so what is this my value? Okay, drop is none. Okay, so it is going to drop the first value. Okay, so if you want to study, see, if only one category is present, the feature will be dropped. Okay, so whatever the value you are using, right, it will use n-1 features. Okay, and sparse. Okay, whether you want to create sparse. Okay, I'm not going into detail regarding the sparse, but you can go through this documentation. If not, you can let me know. Okay, but because we don't usually use, okay, that's why I'm not using. Okay, and the data type, the output values which you are creating, right? So I'll show you. So if you want it in the integer, you can use it int 32, or if you want it as float. Okay, I think you also have float. Where is data type, d type? Okay, yeah, you have also float. If you want float, default it will be float. That means you will get in the float values. That means you will have in place of 0, it will create 0.0. In place of 1, it will create 1.0. Okay, or by default, if you use int, it will use 1 and 0. Okay, that's it. So, but the main thing is here, just like how we are using pandas. Okay, just like how we are using simply pt.get pandas. Okay, and you are saying drop first equal to true. Similar thing you can also achieve by same thing. You need to import OneHot encoder, and inside the OneHot encoder, okay, you need to pass drop equal to first. Okay, that means what? It will drop the first column. Okay, you're dropping any column you can drop. Okay, but yeah, you're dropping the first column. Okay, so this is my OHC object. Okay, and that you are doing fit transform. Okay, see, earlier I think we have done fit, then we have done transform. Okay, so now I'm showing you can do the both things at one stretch. Okay, so you can do just fit transform on training data. Okay, then you are directly transforming it on the test data. Okay, so or you can do it in 3 steps, guys. Okay, first you can fit it on train data. Okay, then transform it on training data, and also transform it on, okay, transform it on test data.
Test data.
Getting? Or you can club these two into one. You can directly do fit transform on training data. Agree? And then directly transform on test data. Clear?
Yeah, Santosh.
Yes, sir.
Okay, so I think in standardization normalization, I've shown you this way. Okay, but this is the shortcut. You can directly do fit transform. Okay, directly you are fitting and transform. That means you are learning and also applying on train data. And now since you already learned, you don't need to learn it again. So directly apply. That means transform on test data. Okay, so that is how you are applying the transformation on this and this. Okay, and this is my shape. And now if you see the values, okay, but here, yeah, there is one point I need to mention to you. So here what happens here is, so whenever you are passing the values. Okay, for example, here I am doing transformation on what? I'm doing OneHot encoding on fuel and owner. Okay, so that means what? It is creating the transformed values. Okay, so it is creating the transformed values in this. Okay, this is extrain new. Okay, and now this X test is anyhow we are going to apply. Okay, but that means what? This extrain new will have only the transformed values of fuel and owner. Okay, the remaining columns are like that only. It is not going to touch those values. Okay, the thing in OneHot encoding is you need to take only the columns, let's say C1, C2, apply OneHot encoding, get the OneHot encoding columns, and bring this and attach to the remaining columns, all other columns. Okay, that is one extra step you need to do as in OHC. OneHot encoding. Okay, but here what happens in when you use get the miss, okay, whatever the columns you are going to use, okay, it will directly consider the other columns and it will give you. Okay, but in OHC what happens is when you are applying this OneHot when you're passing OneHot encoding to this specifying these columns, okay, it will create only OneHot encoded values for these columns only. Okay, it will not consider other columns. Okay, so that's why what we are doing, you are attaching the other columns. What are the left out columns? Brand and kilometer driven. Okay, so brand and kilometer driven, you are taking those values, and with these values, whatever these values extra new, you are doing np.h stack. H stack means horizontal stack. That means, for example, this particular row is my brand and kilometer driven. Okay, brand and kilometer driven, and there will be one more row called as OneHot encoded values of fuel and owner. Okay, fuel and owner. These two rows I'm putting side by side. Okay, horizontal stacking. Okay, not vertical. I'm not putting one above the above. I'm putting side by side. Okay, that means now it will become, this full will become one row. Like how, see, it became Hyundai 35,000 till here, brand and kilometer driven. Now, what are these values? There are so many values. It is saying dot dot dot. These all values are for fuel and owner. Getting? For fuel, there will be so many ones and zeros. Okay, and owner, there will be so many ones and zeros. Those values are from here. That's we are concatenating. There is stacking. Same thing for other. Is this part clear, guys, or confusion? I think
Yes, Santosh.
Confusion, right?
No, I mean we have taken one data set and we have trained it.
Yeah.
First,
So for
it
example,
worked.
if you
I mean,
see,
it worked on only fuel and owner.
correct.
So later we have combined brand, kilometers driven. Along with that, we have combined the fuel and owner in the form of OneHot encoder.
Correct. So for example, if you see, when I applied, when I consider only fuel and owner column from the extrain, okay. Now what is the extrain? So see, I'll just show you this example. Okay, so you're doing train test split, and this is my extrain. What is this extrain? This is my extrain. Okay. So after that, I'm importing my OneHot encoder, and in that I'm considering this drop first equal. That's fine. Now to this OHC object, I am doing fit transform on my extrain. That means this row. Okay. For example, let's consider only this particular first row. Okay. So over here, I'm considering only these two columns, fuel and owner. Okay, and I am passing doing OHC. Okay, now this is my output. When you see the output, see how it is looking. So it is only showing fuel and owner, obviously fuel and owner, OneHot encoded values. Agree? So these are my OneHot encoded values of fuel and owner. Okay, but this row also has brand and kilometer driven. That will not directly be shown. Okay, but in get damage it will show. Okay, get damage it will directly show with other columns also, but in OHC you need to do one more step. Okay, that's how this library is built. Okay, so here it will show only this particular row. Okay, same thing for all the rows. Okay, see, all these rows are just OneHot encoding values of fuel and owner. Okay, and but now you also have OHC.transform. Okay, this for test. Okay, so now you have transformed the values of exchange, but you also have the values of brand and kilometer driven. Okay, you also have values for brand and kilometer driven. Agree? So what are these values? These two. Okay, so those values we are taking it as values. Okay, from exchange you are taking those values. Okay, and whatever the new values are there, these are the OneHot encoded values of fuel and owner. Okay, those values new. Now when you put np.h stack, okay, that means numpy.h stack horizontal stack will just stack. Okay, so from here whatever you seeing this 100 everything, so those are these values. Okay, see, from last to second we are having 100 100. Okay, see this one, last 100, this will be 100. Fine, and the remaining brand and kilometer driven are coming from the extreme. So now this is the row for the encoded values. Okay, this is the row for the encoded values. Okay, but here you might get doubt like you are not encoding for brand. Here you can do for brand also, that's fine. Okay, but just because now, as of now, the brand is having very high number of encoded values, I'm not showing it as an example. Okay, but usually if you want to do encoded values for brand, you can use brand also as encoded values, and then you can combine this. Okay, for example, let's say I am going to use brand also. Okay, so where is my brand? Okay, I'll take this brand. Okay, let me just split it again. Okay, these are my OneHot encoded values, and let me use brand also. Fine, and these are my values. Okay, and I'm using the brand on, see, whatever you're doing it on train data, you should use the same thing on test data also, guys. Remember. Okay, what's happening? Ashok, okay, found unknown categories, Ashok in column 0 during transformation. Achha, okay, so now what is happening? Yeah, what is happening it is when you're doing what is it, train test split, okay, a particular Ashok column went into training data. Okay, and I think there is only one column. Okay, so there is only one column. For example, let me see brand. Okay, see, there is only one row, Ashok. Okay, Ashok brand, that row went into training data. Correct, there is no Ashok in test data. Fine.
Okay.
So
Yes.
that's why when I'm applying this OneHot encoding test data, it is saying there is no value called as Ashok in test data, so it cannot apply. So as of now, so I will tell you how to handle these cases. Okay, even in my current scenario also I have faced this. Okay, you can write a simple code to include wherever you are having the value of 1. So you can make sure that these values will fall only into the training data. Okay, so or what you can do is you can just put them aside and do the OneHot encoding only to the upper values. Okay, and then add them. Okay, so I will let you know how you can handle that scenario. Okay, but as of now, just I'll mark it. Okay, and we'll let you know. Okay, for example, but as of now, let's see on the training data. Okay, so now if you are stacking it on the kilometer driven. Okay, so now these are the values. Okay, so this is for kilometer driven, and these values are for your brand and fuel and owner. Getting?
Yeah, Santosh.
Fine. Meghna, are you following? It's clear to you, right?
Yeah. Yes.
Okay. So that's how you can simply go by OneHot encoding or pd.dummies. Okay. Doesn't matter. Okay. You can create encoded values and now you can pass it to the model. Okay, so now you might get an idea. So in a practical data set, obviously you will have a mixture of different columns like nominal and ordinal. Okay, so wherever you are having, let's say you are having like 2 nominal categories, and let's say you're having 3 ordinal categories. Okay, so for these 2 nominal categories, you are going to apply OneHot encoding. You will get a list of columns, and for the remaining 3 ordinal, you are going to apply these values, then you are going to get those. Okay, then you are going to club this and pass as a model. Fine, so that's how this will be done. Okay, based upon the category. And this is also one more way. So as we have seen, for example, if number of categories, okay, if number of categories is very high, fine. So instead of going for all the categories, you can also put a restriction. Okay, for example, let's say my brand is having, if I check the value counts of my brand, fine. So how many, what is the value counts of my brand? 32. Okay, so wherever if my value, okay, so wherever if my what is this counts? First, let me see the. Okay. So the see in Maruti value is only 2444. Toyota is having 488. Okay, so there are so many like values for each and every category. So you can put a threshold also. That means 100. So only if the threshold is less than, okay, that means count. Okay, for example, whatever this Toyota is having 488. Okay, so only if the value is less than 100. Okay, then only you can go by some OneHot encoding. Okay, or the other way around. Okay, for example, see what it is happening here is wherever you are having this value less than this 100, okay, so you can replace it with some other value. Okay, so if it is this threshold, you can find you can experiment. But here what we are doing is, if the unique values is less than 100, okay, that means it is not that common. Okay, it's uncommon. Okay, because if it is a car brand, so even if it is not having at least 100 values also, that means if even if 100 people are not using, so obviously it's not very common. Okay, it's a very uncommon brand. Getting, guys, what I'm trying to say? See, we are putting a threshold, guys. Okay, see, these are all the value counts of each and every category. Okay, so this, for example, let's say it is having force is having just six values. Okay, that means what? The value counts of force is 6. That means it repeated only 6 times. Okay, this data is repeated 734 times. Okay, so instead of using, if you want, you can go for the OneHot encoding for each and every category. Okay, or if you feel the number of columns that are getting created is very high, what you can do is you can also put a threshold. Let's say here I'm putting 100 threshold. Okay, that means if at all, if the value of any this category is not crossing 100, if it is less than 100, so obviously it is not that common. Okay, there are only few number of cores. Okay, so I will just replace that value with some other category called as uncommon. Getting? So what happens? All this becomes uncommon. Okay, for example, from Nissan. Okay, so all, instead of, let's say these are some 20 values. Okay, instead of saying Nissan Jaguar, and for Nissan it will create some more feature. That means what? If they're having 20 values, so obviously it will directly create 20 OneHot encodings values. Agree? Brand underscore Nissan, brand underscore Jaguar, brand underscore Volvo. Following, guys?
Yes, sir.
Yes.
So instead of doing that, I don't want those. So I will just, wherever I'm putting a threshold of 100. So for all these values, I'm just replacing this value by something called as uncommon. Okay. So all this will be replaced by one single name called as uncommon. Okay. So obviously it will create only one column called as brand underscore uncommon. Fine. So using that also, you can, whenever you are having the value counts, I mean the number of features are going larger. Okay, you can put threshold, and wherever you are having the value as less than the threshold, see there you are replacing it by uncommon. Fine. So for example, this 5335 is it is showing is one common. Okay, so that means it is having some value in this. Okay, getting? So that means this 5335 is having some value falling in this range. Okay, for example, let's see what is this 5335. Can you guys tell me how to see a particular row? Df dot, first of all, what is df? Okay, this is my still this dot ilog, right? 5355. Okay, now what is this? This brand is Jeep. Fine. Now what is this Jeep? Jeep is falling here. Okay, so obviously it is less than my threshold 100. Okay, so this became uncommon. Everywhere you have this value, that will fall under uncommon. Fine, that will be falling under only one column. So instead of having so many features, so it got decreased by, let's say, 20 or 19. Fine. Now with this, along with some other brand values, and you can pass it. Okay, now you're thinking we are losing some information. Fine, so that is to experiment and let find out. Fine, because you can use all the features and find out the accuracy, and you can just replace some values and find out the accuracy, and then you can decide whether this is giving good results or bad results. Okay, but this is just one more way. If you're having, because just assume, guys, if you're having, let's say, 100 in practical scenario, if you're having 100 different categories, you cannot create 99 columns. Fine, so obviously you will come up with some top repeating columns, or like creating a unique column like that. Fine, because as I said, the more number of features it increases, it will fall us into some big issue called as curse of dimensionality. Okay, COD. We'll see this. What does this mean? Okay, we'll come across this again and again. Okay, but that is a point, guys. Fine. So I hope it was helpful. Fine. So this is how practically you can do OneHot encoding. Fine. So with this, I think we have covered all the different types of encodings which we need to cover. Like OneHot encoding, ordinal, mainly these two, and label encoding is for just for the labels. Okay. So wherever you come across the columns, just have an idea about what categorical type it is and just apply the corresponding OneHot encoding ordinal. Obviously, numerical will be numerical. And once you do this, so every complete row will convert into a numerical value. So then it will be fit for further processing or sometimes directly for the model training procedure. Agree, guys? Any doubts? Are you guys followed? Are you guys on track, honestly? Karthik, tell me any doubts.
I mean, till now, today's session is fine, Santosh. Can you please off the record?
I'll share the record and also this notebook and also CSV file.
Can you please stop the recording?
Acha, okay, fine. Before that, Meghana, are we good?
Yes, sir.
Okay, fine.